Today we are going to be talking about something called a combination. And combination and permutation are very closely related. But if you think back to when we were talking about permutations, a permutation is a specific order, okay? So when I'm talking about a combination, I'm talking about a selection of objects without a specific order. So combinations look very similar to permutations. It's up to you to be able to decipher the difference, and that's what we're going to be talking about tomorrow. But a combination notation looks like NCR. So the only difference between a combination notation and permutation notation is the fact that my P for permutation is now changed into a C for combination. So C is standing for the fact that this is a combination. The N, again, this is standing for the number of objects. And the R is doing the same thing again, objects chosen at a time. And so the formula for combination, because it is different than permutation, is different from the permutation formula. And we're still going to have the n factorial at the top, but on the bottom, it's a little more complex. I have r factorial times n minus r factorial. So this is our formula for permutation, and then combination adds that r factorial on the bottom. So we have an example here, 5 combination of 3. So if I was to plug this in, I would have 5 factorial on the top. And then r is 3, 3 factorial on the bottom. And then 5 minus 3 factorial next to that. So if I simplify, really the only thing I'm simplifying here is this 5 minus 3. And that 5 minus 3 would give me 2 factorial. So this is what this looks like. I would do my 5 factorial again, which would be 5 times 4 times 3 times 2 times 1, all over 3 factorial, which would be 3 times 2 times 1. So that's just 3 factorial times 2 factorial, which is 2 times 1. Okay, so before this was your permutation. That was our combination. So now I'm going to multiply the top. 5 times 4 times 3 times 2 times 1. If I multiply that, that gets me 120. Then I'm going to multiply my first set here together. 3 times 2 times 1, that gives me 6. Multiply my second set, that gives me 2. Simplify that, I get 120. 6 times 2 is 12. And then 120 divided by 12 is 10. But I also want to look at a real life example, not just some notation. I want to look at a real life example of a combination. So a real life situation of a combination is something that refers to a jury. Okay? So my real life is 9 out of 12 jurors must agree. Okay, so if you're trying a civil case, at least 9 of 12 jurors must agree on a verdict of guilty or not guilty. Okay, so I want to know how many combinations of 9 jurors are possible on a 12-person jury. So would my 9 or my 12 be my n? Number of objects, n. Would that be the 12 or the 9? Okay, so I would have 12, and then how many of the 12 am I picking at a time? 9. Okay, so then if I was to plug in this formula here, my n again is 12, so I would have 12 factorial on the top, and then on the bottom, 9 factorial times 12 minus 9 factorial. And remember on your calculator that you have a factorial button, so you don't have to do the 12 times 11 times so on and so forth. And just as a reminder, on your calculator, that factorial button is underneath the PRB button, right here, PRB. So I want 12 factorial, so I'm going to hit 12, go over to your exclamation point, and I get a really big number.
Really?
Really big. 479,001,600. So that's just 12 factorial. Okay? And then I need to go up and I need to change that to a 9 factorial, which is 362,800 times, well, 12 minus 9, that gives me 3. I can do that. 3 times 2 times 1 is 6. So I'm going to take 479,001,600 divided by whatever 362,880 times 6 is. And look, it's really not that big. There are 220 ways for me to select jurors that all have the same verdict. Okay? And combinations tend to have a lot lower number, because if I was thinking about, remember when we talked about like how many ways can I arrange A, B, and C for my permutations? When I'm talking about combination, it's basically saying that A, B, C, B, A, C, C, A, B, that those are all the same. Okay, it's saying that all those combinations are the same because they contain the same 3 letters. Okay, permutation is saying that those are all different because they're all in different orders. But we're going to get more into that tomorrow. So I'm going to give you a problem that I would like you to see if you can figure out how many different selections can I have if I have something that looks like this. Okay, so go ahead and plug that into your formula for combinations and see if we can come out to get the same answer.
Either what? Clean out your liquor? No. Like,